Alright, next we have problem 6. Problem 6 asks us to determine the following for a mixer, a 50 ohm system, with the following parameters. So much the same as number 5, but in step D we'll be using high side injection instead of low side injection. So A, determine the input power in dBm. So we have the input power right now in milliwatt, so we can just perform that conversion to dBm. So power of the RF is equal to 10 log of just converting from our power ratio, or sorry, from our watts, back over to dBm. dBm is why we have the 1e minus 3. And so we plug that in, we end up with 15.32 dBm. Alright, so that's what it wanted for A. For B, the mixer's output power in watts. So we're given the output as for 6, sorry I was reading 5 there, determine the mixer's output in watts. So the output's given as 5 dBm. We need to convert that 5 dBm to the watts domain, and we do that just by using the same equation as last time. PIF is equal to milliwatt times 10 to the 5, which was our given quantity, divided by 10 is 3.16 milliwatt for that power in watts. For our CL, our conversion loss, again, is just the RF power in dBm, which we have, minus the intermediate frequency power in dBm, which was this 5. So the conversion loss is just the 15.32 minus 5, or 10.32 dB. Notice this dB instead of dBm because we're talking about the device. Then finally, for high side injection, we want to find the RF frequency using a high side injection system. Determine the frequency of the RF using high side injection. So we know the local oscillator, and we know the IF coming out. So rearrangement of our high side injection formula gives us our frequency of the RF is equal to frequency of the local oscillator minus the frequency of the IF signal. Plug those in from what's given. It's 147 megahertz minus 15.5 megahertz. And we end up with 131.5 megahertz for the high side injection RF signal frequency coming in.